Okay, integration by parts helps us to integrate products. Okay, so if we just consider some of the examples we're going to look at today, okay, you can see here that we've got product, okay, in this case here, the product of x and this bracket, okay, those two are multiplied together. How do we integrate it? Here we've got the product of x sine x multiplied by sine x. How do we integrate it? So we use this method called integration by parts, which is kind of the opposite process of the product rule, okay? So it's based on the idea of the product rule, but we're going to sort of reverse that process now, okay? So when we refer to the product rule, we're obviously thinking about differentiation, all right? And if you remember with the product rule, if we have a product, okay, we have a product of, say, two functions, such that y is equal to uv, for instance then, yeah? Where u and v are the two functions, okay, and we've got the product of them, they've multiplied. Okay, then we know, of course, with the product rule that dy by dx, okay, is v du dx plus u dv dx. Okay, so you've got two functions times together, whatever they are. Okay, if you remember the product rule then to differentiate is given by this here. Okay, so it's this function times the derivative of this function plus this function times the derivative of this function. Okay, now what I can do, I can slightly rewrite this. So dy dx can be written as d by dx of uv. Okay, that's just another way of writing the derivative of the function y with respect to x. Okay, so instead of saying dy by dx, in other words, you know, differentiating y with respect to x, I can say I'm going to differentiate uv with respect to x. Okay, because that's what y is, isn't it? It's equal to uv. So I can say d by dx of uv, which quite simply means the derivative of this with respect to x. Okay, what you get once you differentiate this with respect to x. And of course it will equal to this here. So I'm not going to change this here. I'm going to do v du dx plus u dv dx. Okay. What I'm going to do then, okay, to get this sort of formula for integration by parts, I'm going to rearrange this. Okay. So I'm going to write this so that I've got u dv dx on one side. Okay, so I'm going to keep that on one side and I'm going to take this over the other side. Okay, so I'm going to remove that over there. So I end up having d by dx of uv. Of course, if I take that over, it becomes minus v du by dx. Okay, so it looks a bit strange, but the next step we're going to do then is we're going to integrate. Okay, so when I say integrate, we're going to just integrate everything. We're going to integrate both sides of this equation. So I'm going to integrate this, integrate that, integrate this. Okay, so if I integrate this, okay, and by the way, I'm going to integrate, of course, with respect to x. So if I integrate this, I'll have the integral of u dv dx. Okay, so I'm integrating this. Of course, it's with respect to x, so I've got to put a dx there at the end. Now something interesting happens here then, if you think about it. If I differentiate this with respect to x, think about what I end up with. Okay, well, if you think about what this means, yeah, of course this just means d by dx of uv. This just means the derivative of uv. So what happens when I integrate it? What happens when I integrate the derivative of uv? Well, I just get back to uv, don't I? So I don't need to write an integral symbol there, okay, because I'm just sort of doing the opposite process, aren't I? This is like d by dx of uv, the derivative of uv, so the opposite process will just take me back to uv, okay? So I've done the integration there. And then you've got then minus the integral of this v du dx with respect to x. And this is the formula, okay, that we're going to use for integration by parts. Now it looks obviously really messy, it looks challenging. But the good thing is, right, as we'll see in the examples, it's actually really straightforward, okay, nothing to worry about. The other thing as well, it's good to sort of, write this down in your notes, okay, so make sure this is understood and copy down in your notes, but you will not have to produce this in the exam, okay, you don't need to go through this process, you don't need to remember it for the exam, and what's even better is, I'll show you when we go to the examples, this formula is actually in the formula booklet, okay, so you don't need to remember it at all.